Hello. This time we're going to explore a connection between lattice paths, binary strings, and subsets. So here's the question. How many lattice paths are there from the origin of a Cartesian plane to the point 5, comma 2? Well, let's see. Um, what is a lattice path? Well, in a lattice path, we're only allowed to move one unit to the right or one unit up. So one unit in the vertical direction or one unit in the horizontal direction, right? So let's say, right, that for a moment I'll choose to move just like this. So I have right, then up, then right, 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 then up, and finally just right. Okay, that's a lattice path. But let me look at what we just said, right? Because we can encode the directions that we just follow uh, by a couple of symbols. I can say right, I can say up, right, 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 up, right. In other words, the path that I have just described, it's also described as a string of symbols. Right, up, right, 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 up, right. And in fact, this encoding is one-to-one. It's reversible. Right? It's one-to-one and onto, in fact. It's a bijection between encodings and lattice paths. So what I have, for example, here's another one. If I'm provided with this, right, 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 up, up, and then followed by right and right, I can follow the instructions, and I'll use a different color just to signify it. Well, it goes more or less like this. Right, 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 up, up, right, right. Ah, there we go. So this string encodes the green, while this string encodes the red one. But now it seems that it's a little easier to count these binary strings on the symbols R and U. How so? Well, imagine, right, that you want to come up with a process that generates these strings, right? That generates a string like this. Right? Well, let's look at the number of symbols. We have one, two, three. Well, not the number of symbols, but the number of places, right? The length of the strings. We have 7, right? Okay, so let's say that you have 7 spots. 1, 2, 3, 4, 5, 6, and 7. And I have 1, 2, 3, 4, 5, 6, 7. Now, what is it we can do? Well, from 7, pick, select, choose 2 to place a U. But this instruction that we have here is the same as to say from this set 1, 2, 3, 4, 5, 6, 7, select a subset with 2 elements. Of course, for the case of the red lattice path, we have that we're selecting, well, we have 1, 2, 3, 4, 5, 6. We're selecting 2 and 6. Right? Well, on the green path, right, we're selecting, well, 4 and 5. So let's say that we follow this selection, the one of the red. So we impose those symbols, U here and a U here. Well, now what remains is to select the places for the R's. But while selecting the places for the R's, well, you have to select them all. So you place them all. And then you start. Well, red, right, 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 right. Boom. We're done. What does this mean? Well, that now we managed to count all the strings fairly easily, right? How so? In this problem, is now reduced to count the subsets of cardinality 2 of a set containing 7 elements. But we know how to do that, right? That is simply by symbols C of 2 plus 5, comma 2, which is C of 7, comma 2, which we know by a formula involving the factorial. This is 7 factorial divided by 2 factorial times 5 factorial, which, well, of course, we may reduce to 7 times 6 divided by 2 times 1, which just reduces to 7 times 3, which ultimately is just 21. So there are 21 such strings, meaning there are 21 such subsets, meaning there are 21 such lattice paths. So here's a question for you to answer in the comment area, right? How many such paths, lattice paths, are there from the point AB to CD, where A is less than or equal than C, B is less than or equal than D, and A, B, C, and D, of course, are all integers. Okay? I'll leave that question, and I'll see you next time.